Hey, uh, let's discuss um, the snow effect of the falling snow effect. So here I've created few versions of the snow that we could actually use in our scenes, since um, there's different approach of the falling snow, right? So here I have a simple um, sphere type snow. Here I have um, the piled grids with some textures, snow. All right. Here we have a single type, um, a single grid snowflakes, which are spinning and falling. And the last one is the uh, simple snowflakes, um, the sprites that we can also use in our some um, curtain type um, animations. Okay, so starting with the simple, I guess. So here's the simple sphere, and a little deformation is applied to the snowflake. Let's say a piece of snowflake, and um, here I'm using the particle system with the p scale applied to it. All right, and then I'm adding attribute randomize node to randomize my normals so it could face different directions. Okay, and um, here I'm using our camera to create if you notice, we have our camera being used as a distant field. All right, so um, we have our camera being imported into the WOP node, and here we're using the positions of both, subtracting and using the length of the subtracted vector. I mean, of the result of the subtraction. We're using the length attribute, length of this vector, and fitting to our um, fitting our lengths and putting into ramp, so I could use uh, the fading multiplier, let's say, and we're multiplying everything to the color, putting back to the color. Okay, so this way, so here I have my min and max. If I start, so they're all dark. It's a fake effect the of creating the depths, imitating of depths. All right. Of course, you can use the depths, but you may also use this as like viewport rendering in the viewport. All right. Uh, so this way I can control my depths. All right, as you see. Uh, so we have like an imitation of the depths of the scene. If I simply delete this, all of the particles the same color, feels like the same depths. All right, but this way you can cheat a little bit and create the illusion of depths by coloring the further particles into a darker color. All right, and simply by adding this uh, in the compositing uh, process, you can um, get a nice um, depth effect. All right. Another thing that I'd like to discuss, so some particles are moving too close to the camera, which we probably don't like. So let's see, I missed one. So here, and yeah, my sprites are very low resolution, and I'd like to use again the camera, uh, um, and I'm using the same distance. So here again, we're using our camera, subtracting, and using the same method. And this way, we would like to use the distance to affect our uh, p-scale value. Okay, so this way, objects closer to camera, we can smaller them, or simply just turn them into zero. Okay, and here's the uh, fitting value, the distance that we would like to use. So let me turn this off. As you see, I have bigger the screen. So I can control this value as well. So if I just this way, we kind of avoiding the distraction when those particles just run all over the screen. Right, might turn them into zero. And all right, so this what we've done. So the main idea, we're using very basic shape with our particles. We're using the normal randomizing normal RP scale and distance from the camera to get illusion of the depth effect, and getting and solving the problem of particles that come across too close to camera. All right. Um, yeah. Um, the next effect is the, let me just switch. Um, so as my personal observation, the snow is the few snowflakes being collected into one piece, and they fall down. All right. So here I created the illusion of that. So here I have a few. All right, something like this, and here again we have a particle scale, but it's all right. Just turn it off. Here I've created a particle scale again, random normals, and the depth fade as well, right? So if I just turn off the specular, so this way, as you see, we're also controlling the depth value, and I'm promoting here. Here I haven't actually. So here's my sphere. so I'm giving a little bit deformation, and I'm doing a randomized normals inside the sphere so I can have them placed differently. And here I'm creating a p-scale for each point, so they would be different size. Okay, and here I'm adding this custom attribute value where it just looks into this directory of snowflakes that we have, and create this attribute for each point of this geometry to create random snowflakes, and on a separate grid. Okay, and then we simply copy all of this to our particle system. All right, so here I'm using the camera, and as you see, we have our particles being falling, and then I'm uh, copying this. I'm promoting this image attribute from points to primitives, just to be used in the rendering. So if I switch to the rendering, we just kill the motion blur. So as you see, let me do and do like let's multiply equal by channel. I'd like to lower down my velocity attribute to just to have some um, and so here in the material library I'm using just here I'm creating this I'm using this attribute this material. Okay, so I'm using those snowflakes um, that we have, those random snowflakes. All right, that we have separated and keep them in one folder, right? Um, and here in the material library, I'm just looking to this material, all right, and I'm applying it to our geometry. And so, and here I'm using the motion blur. Let me feels like it's not affecting it. Let's do next. Let's add trail here and compute velocity. All right, this one works. Okay. So in some cases, you probably would like to use this type of method, which actually gives some nice. It's like a second level of using the first method. So where you have a blob type of snowflakes falling down, here you have some pattern. Okay. And the next one, okay, here we have our reference. The next one where we're using simple cards as the snowflakes. All right, so here I have a grid with UV texture and some distortion of the grid. I'm extruding so I can see my snowflake on both sides, but I don't think it's necessary. So here's my snowflake, and I've rotated. All right. So here's the result. I extruded because the backside of this card looks a little distracting. So here I have my particles spinning, uh, but here I'm adding the p scale to my particles. Okay, and then I'm adding some normals to it. Let me turn this off. Yeah, I think that's a better position uh, to our particles. All right, so here I'm adding normals and up vector, and also I'm creating the that image attribute, uh, looking to my snowflake folder to all my snowflakes. So here I'm what I'm doing here. All right. Um, Here I'm using my camera again, but um, just to face my snowflakes to the camera. Okay, and wait just a moment. All right, these are the same process that we've done in the previous versions of the snow. Here creating the depths as usual. Here we're using again our camera just to get rid of um, those particles that are too close to the camera. All right, and next I'm using here point um, with the normals and up vector applied to it. Okay, and I'm using this expression VT origin and VR origin to link this point to my camera. So this way I could have so here, and if I just look to my up attribute, all right, and we'll see our camera. So as you see, I have the placement of my point just exactly in the center of my camera with the normal and up vector applied to it. And I'd like just all my particles. If I would use the subtraction method, let's say. Uh, like I'm doing it in here. Let's see. As you see, as you see here, all the points are pointing to the camera, but in a snowflakes in a way of looking, seeing snowflakes. I want them to be parallel to my camera. So this way, I'm using this this normal that is the direction of our camera as a reference. So this way I'm creating not this kind of result which is not desirable result, but this one which will be parallel to our view all the time. Okay, and then we're copying it to our image, to our snowflakes. Let me quickly just and if we look from the camera. All right, as you see, we're now we are facing the camera. Okay, and in the render here, I'm promoting my image attribute that we created, and in the render we have this type of effect. All right, again with the same material applied. All right, why I have created this effect is because the sprites are not rendering in the karma renderer, but you can use mantra in this case. But yeah, this is why I created this method, and also probably what would you kind of uh, use like the main thing is the particle scale, the custom attribute of snowflake image, the this depth effect, the type of illusion probably might be also need to use in some cases, and this cleaning the those camera the objects that are closer to camera, all right, which probably also is needed, and also to create this type of attribute to and uh, to view value cards as the sprites. All right, so I've turned this off so you can see um, how this works, which is um, not very efficient in my opinion, because we have this. If I turn this off, maybe visible more. So in this case, it kind of looks like moving like in a spherical direction. Okay, not the parallel, but in spherical direction, as you see. But in this case, yeah, exactly, they just simply parallel direction. Okay, so also I think it looks very nice. All right, and the last effect, which is the particle sprite effect with the particle scale and this depth fade effect applied to it, which is uh, also usable. You can render it from the viewport, probably what I do in this case, because my mantra doesn't work. So here's the green as an emitter scattering some points. It's a particle simulation itself. Okay, and so we have our scattering points and our particle system. Okay, so here's a particle system, nothing special. um, Sourcing the burst, some uh, life expectancy. Okay, and here I'm adding a p-scale just to visualize my particle. If I just turn this off, it will be too big to see what's going on. Some forces, all right, gravity and attribute, which gives this type of effect, and drag, and most important is this pop sprite effect. So here I'm using a texture, my texture which has like 3 by 3 snowflakes, and I'm doing a texture crop sprite sheet 3 by 3, and uh, you can just use the pass through, which gives you all of the attributes that you can, all the parameters that you can change. So in this case, uh, I've used the texture index, which will crop 3 by 3. I'm using the ID of the particle, which is modulus by 9. So in this way, it's like 1, 2, 3, 2, 9, and then 0, starting from 1, 2, 3, and 9 again. Okay, and the channel scale, I'm not sure. Let's check. Well, you can use it as well, but no, it's in this case okay. I have actually, I have this attribute, sprite scale. Oh, here I have custom scale, right, that I've created. Just refresh. No, I don't think that I'm affecting my texture scale in this case, only this one. So texture index. So texture index in this case that will be used. So here's the ID attribute modulus by 9 in my case, because like I said, I have 9 images um, of snowflakes. And yeah, this is about it, and this type of effect we're having. So I can render it with a higher resolution and just screen onto add a screen uh, in the compositing process. Okay, but if I try to render it, you see it renders as simple spheres. Okay, let me try to line copy. Let's see. I'm just wondering whether if we can render the points as the points, right? Which is also actually, if I simply just do this way. So if I pin this and try manipulate my p-scale value, yeah, it does work, which is good. And let's see, we have lines. Yeah, it works. I think this also very, very nice to have. So as you see, we can have a few types of snowflakes with some custom add-ons of creating illusion of depths and um, cleaning up the front of our view um, to have no distracting objects in the front of a view of our camera. All right, and yeah, that's all that I'd like to share. Hope you liked the lesson. If you find it useful, please subscribe. Thank you very much. Good luck and goodbye.